This is Math 139, Section 4.8. We're now going to turn to simplifying radicals when they don't come out evenly. We'll be adding the extra issue of variables under our radical, but you actually already have some experience with the numerical portion of this section because we've done some of it when we've been simplifying our radicals inside the quadratic formula. Remember how we were splitting up our numbers into a perfect, in our case, perfect square, but we'll now say perfect nth power, times whatever else is left. In this first one, the square root of 54x to the 6th, I'm going to say since the square root of 54 does not come out evenly, I want to think of a perfect square that goes evenly into 54. And I think I'll break that 54 down as 9 times 6. The square root of 9 is going to come out evenly, so I'm happy with that. Now, the variable part. In this case, x to the 6th is going to come out evenly. I can divide 6 by 2. It's just going to be x cubed, right? So for right now, I'm going to put the x to the 6th with a 9. Everything under this first radical, I want to be able to take the square root of evenly. And that's exactly what I'm going to do next. Square root of 9 is 3. 6 divided by 2 makes that x to the 3rd. And then that square root of 6 simply doesn't come out evenly, so I have to keep it. And that would be considered a simplified radical. All right, let's try a few more like this. Square root of 75x to the 7th. Once again, I want to split this up into two pieces. The first piece I want to be able to take the square root of perfectly. The second piece is kind of like what's left over. So a perfect square that goes into 75 would be 25. We'll go with 25 times 3. And then what about that x to the 7th? This is a square root, and you can't take 7 divided by 2 and have it come out evenly. So what I'm going to do is I'm going to say, well, the closest even power I would have here would be x to the 6th. That is divisible by 2. And the extra x, I'll put over there in the second radical. Square root of 25x to the 6th is 5x cubed. And then the square root of 3x doesn't come out evenly. All right, number 3. This is one of those where we've got a whole quantity raised to the 13th power. So I can work on this, but I do have the same problem I had in the last one. With an odd power, I can't divide by 2 and have it come out evenly. So once again, I'm going to split this up. This quantity 4x minus 1, I make the closest even power, so I'll say the 12th. And then the extra, 4x minus 1 to the 1st, we'll put in the second radical. Here, 12 divided by 2 is going to make that a 6th power. And then the square root of 4x minus 1, I cannot do. Doesn't come out evenly, so we'll just leave it there. All right, one more square root. I've got a couple separate variables here, but notice everything's multiplied, so it is okay to separate. And I'll start with that 80. The biggest perfect square I can think of that goes into 80 is 16. I'm going to go with 16 times 5 here. 9 as an exponent. 9 divided by 2 is not going to come out evenly. So I'm going to split that up, a to the 8th, a to the 1st. B squared, yeah, 2 is divisible by 2, so that's fine just the way it is. And again, notice I've collected all the stuff that's going to work out, things I can take the square root of in this first radical, and then the stuff that's kind of left over is in the second. All right, let's do our square root. 4 x to the 4th That'll just be b to the first, so I'll just write it as b. And then still in the square root, 5a, because it does not come out evenly. All right, let's turn to some other indices. So far we've done all square roots, but we're going to do a similar kind of analysis here with a couple of cubed roots in 5 and 6. Just a reminder again, you may want to remind yourself what some of the most common perfect cubes are, because when we separate our radicals, we're going to want to know which of these perfect cubes go evenly into our value so that we can take them out. So here again I've got a product, so it's okay to separate. And I need now a perfect cube that's going to go into 54. Well, looking at my list, 3 cubed is 27. 27 is just, 27 times 2 is 54. So let's separate the 54 that way. Now, x to the 6th is actually fine. 6 divided by 3 is going to work out perfectly. So I'll just leave the x to the 6th alone for the moment. All right, we take our cubed root here. Cube root of 27 is 3. And dividing my exponent by my index gives me x squared. The cubed root of 2 does not come out evenly, so it's still part of the answer. Let's do one more cubed root. I do have a product, so it's okay to separate. And first of all, I'm looking for a perfect cube that goes into 40. Looking at my list here, I don't think I can come up with anything bigger than 8. So let's go with 8 times 5. X to the 10th, 10 is not divisible by 3. So the closest one that will work out would be x to the 9th. 9 is divisible by 3, so I'm happy with that. And then the extra x to the first goes into the second radical. All right, the cube root of 8 is 2. Dividing here gives me x to the third. And then the cube root of 5x doesn't come out evenly, so I just leave it in my answer. All right, looks like I was mistaken. We do have one more cube root problem to do. Number 7 here. The cube root of 4,000, m to the 14th, n to the 4th. All multiplied together, so once again, perfectly okay to separate that into the product of 2 radicals. And on that 4,000, I'm thinking all the way down here to the 10 cubed. 1,000 times 4 is 4,000. All right, the exponents. Can't divide 14 by 3 evenly, so the closest I can get to that would be m to the 12th. 12 is divisible by 3. And then I still have m squared left over for the total of m to the 14th. Again with the n, can't divide 4 by 3. Closest I can get would be n to the third. And I'd have an extra n to the first over in the second radical. All right, let's do our cube root here. Cube root of 1,000 is 10. And then dividing the exponent by the index, m to the fourth, n to just the first. And then I still have the cube root of 4m squared n. Doesn't come out evenly. By the way, just sort of a word to the wise here, this is a time when neatness really does count. Be careful when you have things like a cubed root, that little 3 there is very clearly the index. It's kind of in the little indent there of the radical sign. It's really easy for those 3's to start spilling out and start looking like an exponent on the n, and that's not what we mean. So be neat enough to be precise. All right, we'll turn to one example of a 4th power. I do have a product, so it's okay to break it up. In 4th powers, I don't know nearly as well, but as I look at that 6250, and I compare that to my list of 4th powers, 5 to the 4th is 625. So I'm thinking 625 times 10 sounds pretty good. All right, with the x, I need to be able to divide that exponent by 4, and I can't right now. In fact, the closest I can actually get is x to the 12th. That is divisible by 4. So I'll have an extra x cubed over here for a total of 15. The 4th root of 625 was 5, and dividing the exponent by the index gives me an x cubed. The 4th root of 10x cubed does not come out evenly, so I'm just going to leave it as part of my answer. All right, that's the end of part A of this section. We will continue in the next video.